Dot product and cross product are the two methods of multiplying the vectors. Therefore, understanding the vectors and the properties of vectors is very important. Before going into how to do the dot product and cross product, let's do a quick review of vectors and its properties and refresh our memory on that. So over here, I have the x-y axis with vector A in it. Every vector has the x and the y component in a two-dimensional plane. So here our vector A has ax and ay. So in order to get the x and y component, so basically the start of the vector, the end of vector on the x-axis gives us the ax, which is going to be that, and the ay is going to be this on the y-axis. So this is going to be ay. And then we also have the angle theta that it makes. So if we bring it down and simplify it and put it in a right triangle to use the sine and cosine to get the parts, that's how it's gonna look like. So that's gonna be our vector A. Then we have a y, and then we have so that is a y, ax, and that is going to be our theta. Now, going back to trigonometry, the sine of theta is equal to basically opposite over hypotenuse, which in this case, opposite is ay and the hypotenuse is a. So ay over a gives us the sine of theta. Now, to get the component ay, so solving for ay gives us a sine of theta. Now, cosine of theta is equal to adjacent over hypotenuse, and adjacent is ax over a, and therefore the ax is going to be a cosine of theta. So ay, ax, a sine of theta, a cosine of theta. So but these are the components, how we derive them. Now we have the vector A, so vector A, and if you want to get the magnitude of it, we basically do the absolute value of it, and that gives us the magnitude, which is gonna be a x squared plus a y squared, and that is equal to the magnitude of the vector. And the other formula that we have, and we usually use that to get the angle of our vector, is using the tangent. So we know that the tangent of theta is equal to sine over cosine, sine over cosine of theta. And if we do the sine over cosine, what do we get? We get ay over ax, ay over ax. And if we get the tangent inverse of ay over ax, that gives us the theta, the angle of that vector. So this is the very basic of vectors that we are going to need them to know in order to do the dot product and cross product. Let's go ahead and start with dot product. So what is the dot product? Dot product is, let's say we have the two vectors u and v. So vector u is equal to u1 and u2, and vector v is v1, v2, and we want to do the dot product of u and v. So one other note here, there are different ways of mentioning and writing down a vector. So this is one notation that we use. So we use the parentheses with the components, the x, the y, and if it is a three-dimension, the z component. The other form that we could use, so here instead of that, I could write the u, the vector u, as u1, u2 in a matrix form. Or I could also write u as ui plus uj. So u1 and u2. So there are different ways of showing and writing down a vector. We will use different methods of it to do different examples. But for now, let's say these are the two vectors that we have and we want to do the dot product. When we do the dot product, the result of the dot product is going to be a number. It's not going to give us another vector. So, and multiplication of the dot product, the corresponding terms multiply by each other and they give us a value. So u1, v1, so it's going to be u1, v1 plus u2, v2. And that's how we get the dot product. Now, if we had the vector, let's say vector x as x1, x2, and x3, and we had the w as w1, w2, and w3. And if we wanted to do x dot w, we did the same thing. So x1 w1 plus x2 w2 plus x3 w3. And the result would have been a number, a value. Now, this is the very easy. So let's go ahead and do one example. So let's say that vector u is equal to 1, 2, 3, and vector w is equal to 3, 4, 5. And we want to find u dot w. The way that is done, 1 multiplied by 3 plus 2 by 4 plus 3 by 5. We get 3 plus 8 plus 15, and that is going to give us 26. And that is the result of u dot w vector. Now, as we said before, in order to get the length of the vector, so if we have the two-dimension, we said that the vector u, the length of it, is going to be the first component plus the second component. And if there are three components in three-dimension, squared. So this is the root value of the first component squared plus the second component squared plus the third component squared. And that gives us the length of our vector. Now that we mentioned the length of the vector, there is another important formula that we use to get, it involves the magnitude and the angle of the two vectors. And that's as follows. So if we have the vectors v and w, the dot product is equal to the magnitude of the vector v multiplied by the magnitude of the vector w multiplied by the cosine of the angle between them. So if we have the two vectors u and vector w with the angle between them, if we get the magnitude of this vector, the magnitude of that vector multiplied by each other, multiplied by the angle between them, is going to give us the resultant of the dot product of the two vectors. We normally use this vector to get the cosine of theta. So the cosine of theta from that is going to be v dot w divided by the magnitudes multiplied by each other. And that is the angle theorem. That is the angle of between the two vectors. And that's how we solve for the angle. Now let's go ahead and do some examples of dot product, and we will go over the properties through the examples, how to do them. So let's say for our first example that it says that the vector v is equal to 2, 1, vector w, 1, 2. And it's asking us to find the cosine of theta is equal to how much? The very first thing that we need to do is finding the dot product of the two. So v dot w is going to give us 2.1 plus 1.2, and that gives us 4. The next thing that we need to do is find the magnitude of each vector. So v, the magnitude of v is 2 squared plus 1 squared, and that gives us root 5. Then the magnitude of w is equal to 1 squared plus 2 squared, and that also gives us root 5. Cosine of theta was v dot w over the magnitudes of the two vector multiplied. So we had 4 as v dot w, the dot product, and then we have root 5 multiplied by root 5, and that gives us 4 over 5. So the cosine of theta is equal to 4 over 5. And then if we need the theta, we can do the cosine inverse. Now, let's go and do another one. So the next one is telling us that the vector v is equal to 5i minus 8j, and vector w is equal to I plus 2j. And then we want to find the dot product of them. So v dot w, so 5i multiplied by 1i. So 5 times 1 minus 8 plus 2. So let me put this one, put it in the parentheses so we know what's going on. So it becomes 5 minus 16, and then that gives us negative 11. And that's how we do the dot product of this one. The next example, it tells us that the vector A is equal to 0, 3, negative 7. And vector B is 2, 3, and 1. And now the dot product. A dot B is equal to, well, 0 times 2 plus 3 times 3 plus negative 7 by 1. Negative 7 by 1. So we have 0 plus 9 minus 7, and that gives us a 2. And that's the multiplication. Now let's do another one, but this one is a little bit different. So this example, it gives us a few vectors, and it then says which one is parallel, which ones are orthogonal, or neither. So The first one says A vector is 6, -2, and -1. Vector B is 2, 5, and 2. Now, the properties are as follows. So, if the vector A multiplied by vector B gives us a value of 0, that means the two vectors are orthogonal. So the angle between them is 90. So the cosine of 90 is 0. So you remember cosine of theta is v dot w divided by that. So the cosine of 90 is going to give us a value of 0. So this one needs to be 0 to give us the angle 90. So that's where it comes from. So if we solve it and we get a 0, that means the two vectors are orthogonal. Let's solve it and see what we get. And if it's not 0, then we need to figure out if they are parallel or not. Let's do the first one. So A dot B is equal to 6 multiplied by 2 plus -2 multiplied by 5, -1 multiplied by 2. It gives us 12 minus 10 minus 2. And that is equal to 0. That means these two vectors have an angle between them is 90, so they are orthogonal. Now, the second part of it, the two vectors are vector u is equal to 2i minus j. Vector v is equal to -1/2 I plus 1/4 j. And let's do the multiplication. U times v, so 2 multiplied by -1/2 plus 1, -1, multiplied by 1/4. And what we get here is going to be -1 and -1/4. We do the common denominator and we get -5/4. So u dot v, it gives us -5/4. So they are not orthogonal. So there is the angle between them is not 90. Now, the other properties, it says that when they are parallel. So if the angle between the two vectors is 0 or 180 degrees, that is going to give us the parallel vectors. So how do we know that they are going to be parallel? So here, the angle of 0 gives us what? Gives us a 1. So that means that this needs to be equal to this. So the numerator and the denominator have to be equal to give us a value of 1 for our theta. The cosine of 180 degrees is a -1. So that means that they need to have the same value, opposite signs. One of them needs to be negative. So if we want to write it down, it says that A and B, the dot product, if it is equal to the magnitudes multiplied, that is going to give us a theta is equal to 0. And if A dot B is equal to the negative of the magnitudes multiplied, that gives us a theta of 180 degrees. So if we prove that one of these is true, they are going to be parallel. Now let's go ahead and see if that's true. So I have the dot product. I need to find the magnitudes. So the magnitude U vector is going to be what? 2 squared plus negative 1 squared. And that gives me 4 plus 1, 5 root 5. And the magnitude of V is going to be negative 1 half squared plus 1 over 4 squared. And what does that give me? That is going to be, let me write it down. So it's going to give me 1 over 4 plus 1 over 16. And that is going to give me, the result is going to be root 5 over 4. So the 16 comes out, becomes 4, and then we have 5 in the numerator. So root 5 over 15. If we multiply these two, so U dot V, the magnitudes, is going to be root 5 over 4. And that gives me 5 over 4. I have negative 5 over 4 as the dot product. So the second property is true. So here A dot B is equal to the negative of the magnitudes multiplied by each other. So the angle between them is 180 degrees. So these two vectors are parallel. Now let's do one more example of the dot products, and then we will move on to the cross product. For this example, we have a vector P, which is equal to 2, 8, and negative 1. And the vector Q is x, negative 1, and 2. And the question is, for what value of x theta will be equal to 90 degrees. That means we want these two vectors, we want to make these two vectors orthogonal to each other. So what should be the value of the x to give us that angle? So as we said before, in order to have the angle 90, A dot B should give us a value of 0. So P dot Q should basically here give us a value of 0. So let's do the dot product and put it equal to 0. That means 2 multiplied by x plus 8 multiplied by negative 1 plus negative 1 multiplied by 2 should be equal to 0. So that means 2x minus 8 minus 2 is equal to 0. 2x minus 10 is equal to 0. 2x is equal to 10. And x is equal to 5. So if we have the x is equal to 5, that would satisfy the condition of A dot B is equal to 0, and our angle between the two vectors will be equal to 90, meaning the two vectors are perpendicular or orthogonal to each other. Moving on to do the cross product. Cross product. Well, when we do the cross product, let's say we have vector A multiplied by vector B, and we are doing the cross product. When we do the cross product, the result will be another vector, vector C, let's call it. In the dot product, we said that the result is a value, a number that we get, not a vector. But the cross product gives us a third vector. And that vector C is going to be perpendicular to both of these two vectors. Both C is perpendicular to B, and C is also perpendicular to A. So the formula for cross product is a little bit similar to what we had for the dot product. But here we have A cross B, the magnitude of it is equal to A B sine of theta. So instead of cosine, we have the sine of the angle between the two vectors. So, and in another term, if we want to write it, so it's going to be C, small c, meaning the magnitude of the resultant of the cross product is equal to A B sine of theta, and then sine of theta, well, it's going to be C over AB. Now this comes handy later on, but basically we need everything about the two vectors to be able to get this, and it only gives us the magnitude. It doesn't give us the vector itself. Now, how do we do the vector multiplication? In order to do the cross product and get the vector multiplication, we need to write the two vectors a little bit different and in a form that it's easier to visualize. So this is one way of writing it that we have said before. So we have AXI, AYJ, and AZK, or A1, A2, A3, and then we have the unit vectors I, J, K. The same way is going to be vector B, so BXI plus BYJ plus BZK. Or if you are just given vector A as A1, A2, A3, this is our vector, so we know that this is the I, this is the J, this is the K, multiplied by those unit vectors. It's easier just to see. Now, to do the multiplication, we say A cross B, the two vectors A cross B, and how we write it. So we need to do a 3 by 3 matrix. The first row is going to be I, J, and K, the unit vectors. The second row is going to be the components of the A vector. So it's going to be AX, or A1, A2, A3, AY, and AZ. The third row is going to be the second vector that here we have vector B. So BX, BY, BZ. And we do the multiplication of the 3 by 3 vector, and that's how we get the cross product of AB. Now, how to do it? So the first step is that we want to do the I. So I'll circle the I, I'll cover everything else in this row and everything else in that column. And then I am left with what? With a 2 by 2 matrix. And I get the determinant of this, and multiply it by I, and that's all I need for that. So how it's going to be AY, AZ, BY, BZ multiplied by I minus. Now for the second part, I have the J. Cover that column and everything else in the row. So if I cover this column, all I'm going to be left with is that and that. So these two. And let's write it down. So it's going to be AX, AZ, BX, BZ multiplied by J. And the most important part is that here is going to be a negative. And then for the last part, what I'm going to have is the K. So cover this column and those two. What I'm going to be left with is this 2 by 2 matrix. So it's going to be plus, so AX, AY, BX, BY by K. So that's how I do the cross product. And if I get the determinant of this, that would give me the third vector. Now let me go ahead and do the multiplication and see what I get. Okay, for the first one, we do the cross, right? This one and that one. So AYBZ, let me write it. So AYBZ minus AZBY by I minus AXBZ minus AZBX by J AXBY minus AYBX by K. And that is the result of the cross product. So if I do this, I'll have a vector, let's say call it C, and that's how I get it. Okay, now let's go ahead and do some examples and see that how we use this matrix to do the multiplication and get the cross product. Okay, let's say for the first example, I have the vectors A is equal to 3, negative 3, and 1. Vector B, 4, 9, and 2. And I want to do the A cross B. I write my matrix I, J, K. First row, 3, negative 3, 1. Second row, 4, 9, and 2. And I do the multiplication. So we said that for the I, the first column, the first row, and I do the determinant of that 2 by 2. 3, 1, 9, 2. Let me make this 9 a little bit easier to see. All right, I minus J, cover that column, so it's going to be 3, 1, 4, 2. 3, 1, 4, 2. K, cover that column, so it's going to be 3, negative 3, 4, 9. 3, negative 3, 4, 9, and then multiply it by k. Now if I do that, so negative 3 multiplied by 2, negative 3 by 2, minus 1 by 9, multiplied by I, minus 3 by 2, 6, minus 1 by 4, 4, j, 3 by 9, 27, minus negative 3 by 4, negative 12, plus 12. Okay, I do the simplification. So negative 3 by 2, that one, so then negative 6, negative 9 minus 9, so it's going to be negative 15. I, 6 minus 4, 2, j, 27, 12, 39, k, and that's my vector. Now, if this example had a second part and it was asking us to find the area of the parallelogram that these two vectors make. So these are the two vectors A, B, and there is an angle between them and they can make a parallelogram. And if you want to find the area of the parallelogram, the area is going to be the magnitude of the cross product. So, and that is equal to the area of the parallelogram that the two vector A and B make. In order to do that, here we have the vector. All we need is to find the magnitude of it. And as we know, the magnitude is the root of the square of each component. So it's going to be negative 15 squared plus negative 2 squared plus 39 squared. And if we do this, simplify it, the result will be 5 root 70. And that is the area of the parallelogram formed by the vectors A and B. Now let's go ahead and do another example. In this example, we are given three different vectors. So vector A is 1, 4, negative 7. Vector B is 2, negative 1, and 4. And vector C, 0, negative 9, and 18. The question says, use the scalar triple product to show that the vectors are coplanar. When do we have the three vectors coplanar? The property is as follows. So it says that if A dot B cross C is equal to 0, the three vectors are coplanar. So if you look at this, B cross A gives us a third vector. And then we are multiplying it by getting the dot product of a third vector. So we said that if the dot product is equal to 0, what do we have? So the dot product, if it is equal to 0, that means the angle between the two vectors is equal to 90, right? But we said when we multiply the two vectors, cross product of them, and the third vector is perpendicular to these. So B cross C is gonna give us vector D. And vector D is perpendicular to that. and vector D is also perpendicular to that. So if D dot A gives us a 0, that means D is perpendicular to A. So that means that they are coplanar. So it's a little bit difficult to visualize it, but that's how it is. Now let's go ahead and do the triple multiplication. But then how do we write this? So A dot B cross C is going to be the 3 by 3 multiple, the vectors that we had before. So we said the second row and the third row is going to be the two vectors. Let me write that. So 2, -1, 4, then we have 0, -9, and 18. In our cross product, the first row was always ijk. Now, instead of ijk, we put the A vector, which is going to be 1, 4, -7. And the procedure to do it is going to be the same as before. Let me change color and then we will continue with the multiplication. So the first one is going to be 1 by that determinant. So 1, -1, 4, -9, 18, minus 4 by 24018. 24018 plus or -7. Let me correct my mistake here. So -7 by 2, -1, 0, and -9. And then I gotta do the multiplication. So if I do that, the determinant of the first one is gonna be, well, 1 multiplied by the whole thing. So it's gonna be -18 minus 4 times -9. So it becomes plus 36. Minus 4 multiplied by 2 times 18, 36, minus 4 times 0, 0. So that's it. Minus 7, 2 times -9, -18, minus 0 again. So that's that. And this one is 18. What is that? 4 times 36, 144, minus 7 multiplied by that, it becomes plus 7 times 18, 126, and 126 plus 18 is 144 minus 144, so the result is 0, and that proves that the three vectors A, B, and C are coplanar. The other use of this triple multiplication is to find the volume of the three vectors forming by these three vectors. So when it is equal to 0, that means they're coplanar. All three of them, they lie in the same plane. But if it is not, that is going to give us the volume with the base, the area. We said that B cross C, if we get the magnitude of it, is going to give us the area of the parallelogram formed by these two vectors. And if we do the dot product by A, that is going to give us the, basically A is going to be the height, and then that is going to give us the volume. So base times height gives us the volume of formed by the shape of these three vectors. So that's another way of using the triple product, which Sometimes it's just called the a volume product or volume equation.